The first example of two that we're going to do comes from your geometry booklet, page 14, number 6. It's very, very important that we read the statement before we jump to the diagram. The diagonals of parallelogram, there's a special word that we need to highlight. Diagonals of parallelogram PQRS intersect at T. They've given us some information about equal sides and an angle, and we want to prove that this is a rectangle. Prove that this is a rectangle. So I need to come up with a strategy before I start writing out my solution. Remember that if you're trying to prove a rectangle, you have two options. Either show that one interior angle is 90, or show that the diagonals are equal to each other. And because they've drawn in the diagonals for me, I'm going to try and go down that route, the second route, and see if I can get anywhere with that. I see that I have equal sides. I see that I have equal sides here, so I'm going to be able to use an angles opposite equal sides if I can figure out one of these angles. So by angles on a straight line, I can work out that this angle is 60 degrees. And then by angles op equal sides, I can work out that PQT is also 60. Then some angles in a triangle, QPT is 60. So I've worked out that all of those are 60 degrees. And we know that if a triangle has all equal angles, it means that it also has equal sides and is an equilateral triangle. As soon as you have these two sides equal, PT and QT equal, that gives you a hint of how we're going to progress, because this shape is already a parallelogram. And we know that in a parallelogram, the diagonals bisect each other, which means that PT is equal to TR and QT is equal to TS. And there we've shown that the diagonals, therefore, have to be equal to each other. The diagonals have to be equal to each other, which means that we have our rectangle. Let's see how we write that out. Start out with your RTP statement required to prove PQRS is a rectangle. I like to show how I'm going to do it, but this part is optional. I started off with angles on a straight line, then angles op equal sides, then some angles in a triangle. So showing that all of those were 60. This next line, you remember that I said, therefore, PTQ is equilateral. I think most of us would go there, but technically you don't have to write that. The next step is actually the required one. So concluding, therefore, that QT was equal to PT, and this is side opposite equal angles. Side opposite equal angles. I said, but hold on a sec. Because it's a parallelogram, we know that PT was equal to TR and QT was TS. Therefore, the entire diagonal PR is equal to QS. Therefore, PQRS was a rectangle diagonals of parm equal to each other. Our last example today comes also from your booklet, this time page 15, number 8.1. In this example, it's a little bit more challenging because firstly, we're not given any numbers, so we're only going to use the properties. And secondly, we haven't been told anything about the shape. The only thing I can see is that it has 4 sides, so obviously it's a quadrilateral. And they want us to prove that it's a rhombus. Well, we know to prove a rhombus, I first have to show that it's a parm. And once I've shown it's a parm, I can then show that it's a rhombus. So we've got our work cut out for us on this one. Start off with your RTP statement. So we're proving that it's a parm first. I'm actually going to have 2 RTP statements, one for parm, one for rhombus. Before we talk about this portion here, which I said is optional, let's see what the strategy is. So I've got two equal sides, and you should be starting to see that that means that I can use angles opposite equal sides. So that means this angle, that means that this angle, OCF, is equal to D2. And because D1 is equal to D2, that means that that angle I just identified is also equal to D1. Hopefully you see the Z shape there, so I can conclude that DE is parallel to FC. And suddenly that gives rise to another alternate angles. DEF is alternate to F2 because I now have parallel lines. That means that F2 DEF, I can put the star there because those are equal, but I also have a star on F1. I also have a star on F1. So that means that triangle DEF is also an isosceles triangle, and by sides opposite equal angles, I have DE equal. So here I have one pair of opposite sides equal and parallel. Hopefully you see that so I can do my proof. All right, so we started off with our angles opposite equal sides. We said, but D2 is equal to D1, and I'm missing a reason here. That was given. That was given. Therefore, because they're both equal to D2, that means that they have to be equal to each other. And because they're equal to each other, they're alternate angles, and I could show that the lines are parallel. Once I had my parallel lines, then I started using my green pen to equate the ones with the stars. And I said, therefore, the DE was equal to DF, sides op equal angles. And we concluded one pair of opposite sides equal and parallel. But again, I'm not going to stop here because I don't want to know it's a palm. I want to know that it's a rhombus. So we need another Rtp statement. DFCE is a rhombus. This portion, optional. And to remember what we can prove, what we need to show for a rhombus, we either need to show one pair of adjacent sides is equal, or we need to show that the angle at the center where the two diagonals bisect is 90 degrees. Well, looking at the diagram, I already have highlighted two adjacent sides are equal. So I don't really need to do anything. In this case, I've used DE equal to DF, but I could have done DF equal to FC given. So my conclusion, DFCE is a rhombus, adjacent sides of palm are equal. Not the easiest proof, and I'll admit that I had to look at it a couple of times to come up with a elegant solution. And there are lots of different alternatives here. But it's a nice one because it's very much sort of the higher range of the proofs you'll have to do. From here, you should be ready to do today's exercise. I've only given you two problems because, again, the parallelogram proofs that we did yesterday and the day before are the more important ones. So try to do G and I. And if you do want more practice in this same exercise, there's also F and H. So I'm not going to make those compulsory, but if you want more practice, those are there. And I will share the full solutions to exercise 4 with you, so you can go wild. Good luck and have fun.